right, good afternoon. I'm David. I'm the principal engineer from Intelligent Concrete. We get a lot of good questions that come in for us to answer and our thoughts on things. And we had a really interesting one come in this week on cavitation. So what exactly is cavitation? Well, if we're in a spillway or a tunnel and we have very fast flowing water, we get a boundary layer at the concrete flowing water interface. And that boundary layer, if you have the slightest imperfection, it causes a little air bubble. And that air bubble, after a bit, it explodes and creates negative pressure. And that negative pressure is tension to the concrete surface. What's the worst thing we can do to concrete? Put it in tension. So we don't want cavitation for sure. So how do we prevent this cavitation? Well, there's two sort of ideas on that. Well, one is we want the strongest concrete possible to resist that tension. We want to start there. We want to be proactive with the concrete. And then, so the two ways to help prevent cavitation other than the mix itself is we want that surface as smooth as possible, because any little irregularity is going to cause turbulence, and that turbulence is going to cause that little air bubble, and then the little air bubble is going to move down a little bit and then burst. So that's going to be a problem for us. So at slower velocities, we can use the smoothness. But in some spillways, particularly on very tall dams or in tunnels that have a great drop to them, like an outlet works in a dam, we get extremely high velocities because the dams are really high and we need to process a lot of flow. So in that case, solving cavitation is a little different. And when I was at the Bureau of Reclamation and other agencies have done such work as well, we used air slots. So you'd actually have a location of free air that could be sucked into the flow, and that would form a boundary at the water concrete interface, and so that it acts like a lubrication. That air boundary is like a lubrication. Lets the water just slide over, and there's too much volume to form these little champagne bubbles in the flow. So for very high flows, most dams agencies are using air slots, or this idea of adding air into the boundary layer of the flow. For slower velocities, people are working with the smoothness. There's different ways to measure the smoothness, but just think of it as being very smooth, doesn't create turbulence, and so that solves the problem of creating these air bubbles. Cavitation occurs in perfectly clear water. It's a function of the flow. The other problem that's sometimes confused with cavitation, or can actually cause cavitation, is abrasion. If you get abrasion and it causes these little irregular spots from the erosion, from the abrasion, then it forms air bubbles, and then it forms cavitation. So it's sort of a 1-2 punch to start the cavitation off with the abrasion there. So it makes it worse. You get cavitation if it's clean water, and you get abrasion and then cavitation if you have particles in the water. So that's just sort of a short explanation for you of cavitation. Use your best mixes, make them as durable as possible, make them as smooth as possible, and if you're dealing with very high flows, use an air method to input air into the water concrete interface. So that's our answer to cavitation from this week. I'm David. Let's go concrete. Let's beat asphalt.